For this next question in 5.4, you're going to have to match the given function to one of the graphs. So you need to look at your book for this one. Alright, so in numbers 47 through 56, you have those graphs A through J, and then you have the functions. So you have to figure out which one goes with which. The first thing you need to do is, for the one that you're doing, you need to find the amplitude and the period. Because what we're going to do, we're going to use a process of elimination to determine which one of these is the correct graph. And this is what you should do for all of them. So, first thing you need to find is the amplitude. The amplitude is the absolute value of your A. A in this case is 2. So the amplitude is equal to 2. So, you're going to look at your graphs. I'm going to find which ones have an amplitude of 2. So I'm looking at my graphs and on page 415, and I see that A has an amplitude of 2. So I can't eliminate that one. So does B, C, D, E, and F all have an amplitude of 2. G has an amplitude of 2. Now when I get to H, H has an amplitude of 3. So I know that H cannot be the one, so I can eliminate it. Alright, when I look at I can't be the one. It has an amplitude of 3, so I can eliminate that one. And then J also has an amplitude of 3, so I can eliminate that one as well. Alright, so I have 3 eliminated. So my graph has to either be A, B, C, D, E, F, or G. Alright, the next thing I'm going to find is going to be the period. So the period is 2 pi over the absolute, or divided by the absolute value of B, and B in this case is pi over 2, or pi divided by 2. So I have 2 pi divided by pi divided by 2. So here I have a whole number times a fraction, which means I have to take my numerator, the number in my numerator, which is 2 pi, and multiply it by the reciprocal of my number in my denominator, which is 2 over pi. My pi's are going to cancel out, and 2 times 2 is 4. So now my period is 4. So that means I should see a complete sine graph from 0 to 4. So now I'm going to look for that so I can do the process of elimination. So I'm going to look at the periods of each one of these numbers. So going back to page 415, if I look at number 1, this is not even a sine graph, it's a cosine graph because it starts up and doesn't start down. So here, A is a cosine, so it's not even a sine, so I can eliminate that. The next thing, B. B is a sine function, but if I look at one complete cycle or one complete period for sine, it goes from 0 to 4 pi, not from 0 to 4. So I can eliminate B as well because its period is 4 pi. When I go to C, C is not a sine function either. It is cosine. So I can eliminate C. The next one I see is D. D is a sine function, but it has reflected about the x. It's upside down. So it's not, I don't have a reflection, so it can't be D. So I can eliminate that one. The next one is E. E is not even a sine function. It's a cosine function because it starts up. And when I'm saying it starts up, cosine looks like this. That's cosine. And sine looks like this. Alright, so that's what I mean when I say it starts up and it starts down. Alright, so when I'm looking at E is a cosine function, so I can eliminate that one. Alright, so now I see F. F, when I look at that, it is a sine function. It's going from 0 to 4. And that's what the period I needed to be, from 0 to 4. So F is a contender. So I'm just going to underline that one. If I turn the page and I look at G, G is not a sine graph, it's a cosine, so it can't be G. So in this case, my answer is F. And again, I used the process of elimination. I found my amplitude and I found my period, and then I looked at my graph. You need to see whether or not you have a sine or a cosine. If it's a cosine, it's going to look like a U. If it is a reflection, then of course it's going to be an upside down U. If it is a sign, it looks more like a S or a little squiggly line. If it is a reflection, then it's going to be opposite. And it looks like that.